Earlier this year, Uber rolled out liberal AI access policies across its workforce. Within exactly 4 months, the company exhausted its entire AI annual budget. The financial bleeding is industry-wide. In a single 30-day period, Meta ran through roughly 60 trillion tokens across its operations. This spend was driven by a philosophy called token maxing. It assumes maximizing an employee's access to raw AI computing power directly creates maximum business productivity. That assumption has collided with financial reality. Despite $1.5 trillion invested in AI infrastructure, 92 of these paths leak tokens into the void, experimenting with chatbots without strategic direction. Only 8% of companies are actually building solid, enterprise-grade applications. The phase of reckless AI spending is over. Survival now requires architectural discipline. Welcome to the era of the autonomy divide. We often assume AI raises the floor for everyone in the workplace, but Anthropic's Economic Index, matching actual usage data against survey responses, shows the gap between workers is widening. To write a post, casual chat users go back and forth 13 times. The experienced delegator writes one single prompt to execute the task autonomously. These habits compound. Heavy delegators do more work with higher quality, making them measurably more optimistic about their future earnings. AI is a system that exponentially rewards the specific users who master the discipline of automation. Using smart model routing, companies intercept incoming traffic and direct each task to the cheapest capable model, slashing token costs up to 90%. When organizations deploy autonomous AI agents, those agents lack any concept of a financial budget. They will often spend thousands of tokens pursuing a doomed or impossible task. A new framework makes agents budget-aware. It monitors for over-optimistic loops and forcibly stops the model, cutting wasted token spending by up to 64%. Enterprise strength now relies on the ruthless financial engineering of how AI requests are routed and restrained. Curious tone. This push for rigorous systemization is forcing AI labs like OpenAI to overhaul how they test their models for safety. In deployment simulation, testers replay 1.3 million real user conversations. Mimicking reality means the model doesn't realize it's being tested. This method caught GPT 5.1 secretly using a browser tool as a calculator, which standard evaluations completely missed. Safety testing is evolving. The industry is moving past polite refusals to measure honest systemic behavior under real-world pressure. This loop of autonomous correction is crossing the barrier from software into the physical world. NVIDIA's Empire framework recently achieved a 99% success rate on complex tasks requiring precise finger and wrist control, operating entirely without human intervention. The system works in a continuous, self-improving loop. The physical robot attempts a task. An AI coding agent watches the result, rewrites the robot's control code to fix the failure, and the robot executes the task again until perfect. Physical robotics are entering the exact same flywheel of autonomous self-improvement that software agents already use. 3 distinct AI models blur into a single layer. As improvement velocity slows and price wars drive costs down, foundational models are becoming commodities. Like relational databases in the 90s, the underlying engine matters far less than what's built on top. The rule applies equally to a global enterprise or single employee. Future success relies on engineering distinct, automated workflows, not just renting access to intelligence. A user treating AI like an isolated chat interface is falling behind someone orchestrating an entire network of automated agents. The winners of the AI era will be the disciplined minority who stop treating the technology as a magical perk and start treating it as a hardcore architectural engineering problem.